Okay, this is our third example we're going to look at, which involves differentiating. The first thing you'll notice is that our curve here is no longer given as y. They've used f of x instead. Now, if they use f of x instead of y, then when we're differentiating, we need to use something different than dy by dx. And what we use is f dashed x. And f dashed x means you're differentiating with respect to x. Okay. So in summary, if they use f of x instead of y, then we're going to use f dashed x instead of dy by dx to indicate that we're differentiating. So that's what we're asked to do. We're given our curve. We want to differentiate this curve. Now, there's a lot of problems because we've got brackets, we've got roots in it, and we've got x on the denominator. So we need to get rid of all of those things before we actually differentiate. So first thing we're going to do is get rid of the brackets. So we're squaring the bracket. On the bottom line, I'm going to get rid of the root, so I'm going to write that as 3x to the power of a half. We're now going to multiply the brackets out on the numerator. And then that's all over our denominator. Now, when there's more than one term in the numerator and there's only a single term in the denominator, what we can do is break up the fraction. And the way we break it up is we divide each term on the numerator by the denominator separately. So I'm going to divide x squared by 3x to the power of a half. So there's the first fraction. I'm then going to divide minus 10x by 3x to the power of a half. And then I'm going to divide plus 25 by 3x to the power of a half. And what you can see is we're actually working in the reverse, because if I give you this expression here and said to you, write it as a single fraction, you would say, okay, all the denominators are the same, so write it as a single fraction and then just copy all the numerators down. Well, we've actually done the reverse. We've taken the single fraction and we've broken it up into 3 separate fractions. Now, your attention should be drawn to the fractions where x is on the top and bottom. So I'm talking about the first fraction and the second fraction. X is on the top and the bottom. So in other words, we're dividing two indices with the same base. Okay, we've got an indice x in the top and an indice x in the bottom, and we're dividing them. So we're going to use indices rules. Just before I do that, however, let's look at the numbers on the top and bottom of these fractions. You'll notice that the number before x squared here is just 1, so we've got 1/3. So I'm just going to write that as 1 over 3, 1/3. What I'm now going to do is divide the x's. So we have x to the power of 2 divided by x to the power of a half. So when you divide two indices with the same base, you subtract their powers. So it's going to be x to the power of 2 minus a half. And that's going to give you x to the power of 1.5, or 3 over 2. So for our first fraction, we divided the coefficients here. 1 divided by 3 is just 1/3. And then we divided the x's, so we're left with 1/3 x to the power of 3 over 2, which is great news. We're going to do the same with the second fraction, so divide the coefficients first. Minus 10 divided by 3, we'll just leave it as minus 10 over 3. And then we're going to divide the two indices. So we've got x to the power of 1 divided by x to the power of a half. So remember, you divide two indices with the same base, you subtract the powers. So we're going to have x to the power of 1 minus a half, which is just going to be a half. And again, that's quite nice. Now, if we go to the last fraction, there is only one x and it's on the denominator. So our job is to get that up to the numerator. So like we've shown you before, we only move the x to the top line, nothing else, and you do it by changing the sign of its power. So we're going to have plus 25 over 3, and then x is now in the top line, but we got to make its power negative, so it's going to be negative a half. So if we take a look at what we have at the minute, our curve f of x is equal to the following, and you'll notice that there's no brackets anymore, there's no roots anymore, and all the x's are on the top line. So we've now got the green light to go and differentiate. So instead of writing dy by dx, we're now going to use f dashed x, which means we are now differentiating. So f dashed x equals, so the same rule as before, to differentiate you multiply each term by its power and then you subtract 1 from the power. So we're multiplying this term by 3 over 2. So 3 over 2 times 1 over 3 is going to give us 3 over 6. Okay, and then copy down our x and then subtract 1 from the power. So 3 over 2 minus 1 is just going to be a half. And then go to our next term, multiply this term by the power of x, which is a half. So we're going to have a negative times a positive is a negative, and then 10 times 1 is 10, 3 times 2 is 6, so we're going to have negative 10 over 6, and then copy down x, and then subtract 1 from the power. So the power was a half, subtract 1, it's now negative a half. And then finally, go to our last term here. We're going to multiply this term by the power of x, which is minus a half. So we've got a positive multiplied by a minus, which will give us a negative. And then 25 over 3 multiplied by a half is going to give us 25 over 6. And then again, copy down x. And then subtract 1 from the power of x. So minus a half minus 1 is going to be minus 1.5, or minus 3 over 2. So we've successfully completed the differentiation, although there's a few more things we want to do. I want to do a bit of cancelling here. 3 over 6 and 10 over 6 will cancel. I also want to make the powers of x positive for any x's that have negative power. So I want to deal with this one and deal with that one. So these x's are going to slide back to the bottom line again. So 3 over 6 cancels to give us a half, so we've got a half x to the power of a half. Minus 10 over 6 will cancel, that will give us minus 5 over 3. And also I am shifting this x here to the bottom line, so x joins the 3 in the bottom, and then change the sign of the power, it's now positive a half. Minus 25 over 6 is fine. But again, I want to move this x to the bottom line because its power is negative. I want all the powers of x in my answer to be positive. So I'm going to shift x to the bottom line, but by doing that, I need to change the sign of its power. So it's now positive 3 over 2. So it's looking good. All the powers of x now in our answer are all positive, but any x's that have fractional powers, we're going to bring roots back in. So I'm going to write that as a half times the square root of x. X to the power of a half is the square root of x. And then minus 5 over 3. And then x to the power of a half is the square root of x. And then we've got minus 25 over 6. And then x to the power 3 over 2 is the same as the square root of x. And then that's being cubed, x is being cubed. And that's a really good way to leave your answer. Okay, and we've fully differentiated the curve. Again, in the textbook, they probably won't go this far. I would say in the textbook, well, they'll cancel the coefficients, which are fractions, but the book mostly leaves negative powers and fractional powers in their answer. But I do want you to go a bit further than that because, as I keep saying, at some stage we're going to be subbing values of x in, and it's much easier to sub it in into this type of expression than what it would be into something like that.